All right, welcome, ladies and gentlemen. My name is Brian McLogan, and tonight is another open Q&A for week 8. It's kind of crazy. We've already been doing 8 weeks of this, and I look forward to another good live stream and continue doing this. So it is fun for me to kind of go through, see some questions you guys are asking, and then obviously to do my best. I do apologize for being a little bit late. I was just kind of working on, since I reset everything back up, I was making some videos today and some earlier videos today. And for some reason, when I set back up, my green screen was not, kind of working correctly. And then also I wanted to make sure that my last couple live streams, the Wi-Fi was not been perfect. So I wanted to make sure I had everything connected here for you guys to make sure I wasn't going to have any issues like I've had in the past. But I do see a lot of you guys that, obviously since I made this post have been in on the chat, and I do appreciate that. So I see Luis, Jeffrey, Peaches, Genesis, Shayla. See a lot of you guys have been in here, and then also been reaching out to me, since there. That's awesome. And again, just to remind you guys, for those of you that are kind of jumping into on the stream, the way that I want to kind of work through this is a little bit different than I've done, for instance, last year. I basically set this up usually on Sunday or earlier in the day, so you guys can kind of see when I'm going to be going live, so I can confirm based on my schedule. And then also I'll make a post in my community tab. And really it just kind of comes down to people being able to post their questions either in the community tab or obviously on this. But, again, I want to answer questions that are very specific. In general questions, I just try to stay away from, just because there's so many ways I could answer them or create things. And I want to make sure I can be as useful as to you or as to anybody else what I'm doing. So for today, what I have created, or for today, what I've been provided is to solve a trigonometric equation. I'm going to do on the interval 0 to 2 pi because they didn't clarify. We're going to work on completing the square. So we have one where it's just a basic completing the square, and then another one where it's going to be completing the square with the vertex. We're going to solve some absolute value equations. Some absolute value inequalities. And for this one, they only provided one equation, but they wanted me to expand on it, and that's fine. Like if I have, one thing, like one equation, then at least I can go off of, then I kind of maybe have a little bit better idea of what you're looking for. But, and a lot of people just say, solve these types of equations or do this or, that. It's very hard for me to kind of, sometimes, decide what type of equation you're referring to or what types of problems you are, but then also a way to expand. And then we're going to write the factored form across real and complex numbers. So they gave me this one, but since they kind of provided an answer, I decided I wanted to add an extra one. So I'm actually adding some problems in addition to what I was provided. And this one says, find the graph reflected about the y-axis, then graph it. So we're going to look at one. So here's our function, and we're going to find another function that is that same graph reflected about the y-axis. I like that question. That was kind of an interesting one. And then last one is going to be evaluating the inverse trig function. So we have arctan, and these are going to be compositions. And then obviously this one, no, I decided I wasn't going to do that one. So we'll just do these two. Okay, so typically, guys, I like to try to get in around like 5 and 6. I know that I look back in this chat and there's going to be a whole bunch of other questions coming into there, which is awesome. We'll kind of see how long this is going to take. I try to get these live streams at least because obviously I got school tomorrow, like many of you. So I still have things I got to go ahead and prepare for. So I don't have too much time to, add on a lot of extra questions. But depending on how the kind of live stream goes, if I'm able to add in some extra questions for you guys, then I'll be more than happy to do that. So far, everything's looking pretty good. I wonder if this can, there we go. That'd be sweet. All right. I don't really need that actually. Well, yeah, you know what? I'll leave that right there. But so far, everything's looking pretty good, at least as far as the live stream and the health. So that's awesome. And all right, cool. Let me just do some final checks here. And then we'll go ahead and get in with the math. Oh, wow. A.W. Stevens. Nice through that. All right. Deshaun, thank you. I'm still in Algebra 1. Well, that's awesome. I have a lot of Algebra 1 as well as Algebra 2 videos. I'm actually teaching pre-calculus this year, so Probably not a lot of my videos will be exact routine, but however, a lot of my students, for instance, we cover back factoring, quadratic formula, like we did that last class period. A lot of students will forget a lot of that stuff. So, I want to make sure that, a lot of that stuff we go back in through. So, well, thank you, Anthony. That's very appreciated. I really do appreciate the nice, kind words for you, from you. All right, so, well, there you go, guys. I think we got at least a good start. And let's go ahead, as Jeffrey says, let's go. Let's get it started. And Samuel Kruger, I don't have the vertex for prep. I don't problem. Let's just go ahead and get started with these, and then we'll see what we can do. Oh, that was last week. What we got? Okay, so this one's kind of nice here. Let's see. I should have done it in black. Why do I keep on forgetting to do that? Yeah, well, all right. So real quick, if we're doing a trigonometric function, we can think of this as like 2x squared, plus x equals 0, right? And again, if we were going to do this, we'd want to look at, factoring. So we could factor out an x, and then you'd be left with a 2x plus 1 equals 0, and then you could use the zero product property. Now, obviously, that is going to be, that is with a quadratic equation we're using with cosine, but it's the exact same idea. In this case, we're going to want to factor out a cosine of x. By factoring out a cosine of x, we're going to be left with a 2 cosine of x plus 1. Because remember, cosine squared of x, just means cosine, that's cosine of x times cosine of x. Now I can go ahead and set this equal to 0. So cosine of x equals 0. And 2 cosine of x plus 1 equals 0. So therefore, that's going to be cosine of x equals negative 1/2. All right, so I said on the interval 0 to 2 pi, which is basically going to be the unit circle. So let's go ahead and just find the values that are going to satisfy that. So that's a bad kind of unit circle. Let's do it again. All right, so when cosine is equal to 0, remember cosine represents the x coordinate here. So on the unit circle between 0 and 2 pi, I'm seeing two values here. I'm seeing pi halves. That would do that angle, as well as 3 pi halves. Okay, and then when cosine is equal to negative 1/2, now remember cosine is the x coordinate, or is dealing with the x coordinate. So let's just think about when it's equal to positive 1/2. So it's equal to positive 1/2 at that angle, which is pi over 3, right? Because that is that coordinate point. 1/2 comma square root of 3 over 2. So we're looking for the point, though, that's going to have the same reference angle, but in the second as well as in the third quadrant. Well, if it has the same reference angle, basically what that means, it's going to be pi over 3 away from the x-axis. So if halfway around the circle is pi, and we're pi over 3 short, then we could say that's going to be, this is the same thing as 3 pi over 3, right? So if we're pi over 3 short, we can say one answer is 2 pi over 3. And if we're pi over 3 over 3 pi over 3, we can say 4 pi over 3. So those would be your 2 solutions. And again, we're not doing a negative because the angles have to be between 0 and 2 pi. All right, the next one, completing the square. So, I just recognized that one's not going to be as fun, but, well, all right, I'll go ahead and do it. So, the basic idea with completing the square, or the basic kind of one of the purposes that we're looking for, is we want to be able to write our quadratic as a binomial squared. So, for instance, x squared plus 12x plus 144. If I wanted to factor out this equation, I would look at this and I'd say, well, what two numbers multiply to give you 144? No, that's not right. And add to give you 12. That's not what I'm looking for. I'm looking for 36. My bad. 6, 12 divided by 2. Yeah, 36. Okay. What two numbers? I was getting off my head. Sorry. Like I said, there's been a lot of math problems I've been doing today. 36, what two numbers multiply to give you 36, add to give you 12? And you can say, oh, well, that's going to be, x plus 6 times x plus 6, right? Which is x plus 6 squared. Okay? So that is the idea here. This is what we want to create, is this perfect square trinomial. Now, sometimes you can just do this in your head. If you're thinking about this like 12, like what do I want this to be? Like what two numbers are going to add to give me negative 12 that would also add, that would create a perfect square trinomial? So some people can just go ahead and, think about this, and especially when you have an easy like middle term, you can identify what C would be, which is be saying 36, right? Because now we're going to want our binomial squared to be x minus 6 times x minus 6. So therefore, that'd be x minus 6 squared. So the value C that's going to complete the square in this case would be 36. However, for a little bit more difficult problems like the second example, a way to always find that value C is to basically take your B divided by 2 and square it. So if I took a negative 12 divided by 2 and squared it, I would get a 36. So if you can't already do it in your head, because a lot of times, obviously when you have a problem that, is divisible by 2, it's, relatively basic. You're going to be able to, you can figure out what the perfect square trinomial would be just with some practice. However, if you get stuck or you're not sure how to figure it out or you're kind of confused, we can always rely on this b divided by 2 squared to provide us this perfect square. And I think that's very apparent here in this next example. So in this next example, the first thing when completing the square, you're going to want to factor out the 9. And I'm going to factor it out of the first two terms. So actually, never mind, this is not as bad. You factor out 9, that becomes a 2x. Okay, minus 3. All right, now you might think, all right, so a perfect square trinomial with a 2. Now, first of all, let me just kind of go through. This is what I did with my class here. X squared plus 4x plus 4. X squared plus, let's say, 6x plus 9. See, this is a perfect square trinomial, x plus 1 squared. This is a perfect square trinomial, x plus 2 squared. This is a perfect square trinomial, x plus 3 squared. And if you want to do x, so x squared plus 8x plus 16, that is x plus 4 squared. So a lot of times we're going to be getting one of these numbers, and you can just identify, like if you have 8, 6, 4, or 2, you know you're going to want to add 16, 9, or 4, or 1 to complete the square. This one was a little bit larger, so it's not maybe as obvious for some students. But in this one, like you can realize, hopefully you can see that, well, if I have x squared plus 2x and I want to create a perfect square trinomial, I'm going to want to add a 1 inside those parentheses. But let's just kind of do the method, the b divided by 2 squared. So that'd be 2 divided by 2 squared, which equals 1. So again, that's the value, which we already knew, right? You're going to add that inside the parentheses. But remember, to keep the equation in here, you can't just add a number inside the parentheses and on one side of the equation. You have to add and subtract that number. Actually, let's keep the minus 3. So you have to add that number as well as subtract it. But you got to be very careful. When you add a number inside the parentheses, you got to be careful looking at what you're multiplying those parentheses by. In this case, we're multiplying by 9. So you're not really adding a 1. You're adding a 1 that's being multiplied by 9. So therefore, we need to subtract a 1 that's being multiplied by 9. So therefore, we get something like this, x squared plus 2x plus 1. Let's see, that becomes a negative 9. So negative 3 minus negative 9, that's going to be a negative 12. That's a 2, right? Yeah. And therefore, we already know that that is a binomial squared. So that's going to be a 9. X plus 1 squared, I believe, minus 12. I believe the question is, what was the vertex? Well, that's going to be opposite of your h here, negative 12, right? So it's opposite on the inside of the parentheses and then your k. Because to find the vertex, remember, it's y equals a times x minus h squared plus k, where your vertex is just hk. And again, the one kind of thing that I wanted to, explain or kind of verify that, because a lot of students get trouble, why are you multiplying it by 9? Let me see if I can think about the equation I have here. Like 5 times, x plus 1 is not the same thing as 5x plus 1, right? Those are not the same thing. Because when you have parentheses here, that's 5 times x and that's 5 times 1. So we got to be very careful when we see those parentheses. You're not really adding a 1 here. That's a 1 that's being multiplied by a 5, right? So that's why it's that's why you just want to make sure that when you add that 1 inside parentheses, since you're multiplying by something, you want to make sure you subtract that 1 as well as multiply that by the 9. just want to take a quick little one. I'm in the middle of, guys, for those of you that are kind of joining into the live stream, just kind of working through 6 examples. We're going to kind of see where I kind of line up if I have some questions. Feel free to answer put in some questions because a lot of people obviously in this chat, can maybe answer your questions or maybe lead you to, a way to help you think about your problem or maybe even solve your problem. Because obviously I'm not going to be able to get to everybody's questions. I'm working on right now some questions that have already been pre-submitted prior to this live stream. And then I'll work these questions and then we'll kind of see where we go from there. So, all right, on to the next one, which is the solving absolute value inequalities. And I'm not sure if they said solve and graph. I guess that's what we'll probably do. We'll go ahead and graph them. So the main idea, though, when solving a absolute value inequality, they were kind of wondering, like, as far as I think the 7, like what to kind of do with this. And the best way that I can understand the absolute value inequality is, you got to isolate it. So subtract the 7. Okay. So I have the absolute value of x has to be greater than or equal to 9. Okay. Now what we need to do is we need to set up 2 equations, or we need to set up both inequalities because we have to make sure we take into consideration if the absolute value was going to be negative or as well as if the absolute value was going to be a positive. So what happens is we create a compound inequality. So we have x has to be greater than or equal to positive 9 and x has to be we're going to do less than or equal to negative 9. Because if you think about this, if, or not, x is equal to negative 9, x has to be greater than or equal to negative 9, or x is going to be, less than or equal to, that was right. X is going to be less than or equal to negative 9. That'd be like negative 9, negative 10, negative 11, go through. Because again, think about this. Like if x is greater than or equal to 9, right? So like 9, 10, 11, 12, 13. When you take the absolute value of those are going to be true. And when x is going to be less than or equal to negative 9, that'd be like negative 10, negative 11, negative 12. Well, when you take the absolute value of them, they're going to be a positive number, which will still be greater than 9. So the important thing when we're solving the absolute value equation is to go ahead and create, you can basically just drop the absolute value and create there, and then as well as negate the other side and then flip the inequality symbol. So let's go ahead and graph this just to make sure that we are working with some values. So x has to be greater than 9, but less than or equal to negative 9. So 9, and that's going to be, it could be equal to, that's going to be going to the right. Let's put a 0 here, and this will be negative 9. Okay, so basically the values that do not make this true is any number between negative 9 and 9. And again, like that makes sense, right? Because like negative 5 is absolute value is 5, which is not greater than or equal to 9. Or positive 5. Absolute value of positive 5 is 5, which is still not greater than or equal to 9. So you can see how that one works. Now, the only difference here in kind of this case is, again, now we have the really like the exact same case, but we can just drop this. X plus 7 has to be greater than or equal to positive 16. As well as x plus 7 has to be less than or equal to a negative 16. And again, we can go ahead and, work this out to be able to make sure that it, makes sense and works. So these are what we call our kind of 2 cases. And again, actually that and is not going to work. So it's actually been a long time because you can't have and. You can't have something be that, be less than or equal to 9, and be that. So I guess maybe it's going to be an or. It's actually been a while since I did this, so I do apologize. I'm actually not. I have to go back and check. I thought it was a compound, but maybe it's not because you can't be greater than or equal to 9 and or less than or equal to 9. So I guess I'll just go ahead and use the or. And I do apologize. It's been many, many years since I worked through that. And I'm just kind of going on this on the fly. So let's go ahead and subtract a 7. So I have x is going to be greater than or equal to 9. Okay, and that makes sense, right? Or if we subtract here, x has to be less than or equal to a negative 23. And so therefore you think about all numbers that are going to be less than or equal to negative 23. So like, let's just do, negative 25. If you did negative 25 plus 7, that'd be a negative 18. Absolute value of negative 18 is going to be greater than or equal to 16. So I guess it is the or. So all values x are greater than or equal to 9. So again, that's going to be 9. And then let's put a 0 here, and then this one would be negative 23. Okay. Cool. All right. Yeah, now I got to go back and like verify and look at that. So I do apologize if the or buts. But again, as long as it's going to be one or both of those, so it's not going to be and, then that's going to be true. All right, the next one is write the factored form across real and complex numbers. So, basically when we're factoring like a problem like this, we just want to factor it, right? So, here we can have y is equal to x minus 3 times x plus 1, right? What two numbers multiply to give you negative 3, add to give you negative 2, voila. Now, this next example, we can see that this is non-factorable across real numbers. So we basically want to be able to figure out what the irrational or complex numbers are going to be that we can write this. And again, that we can write this as a product. So a couple ways to understand this. If, when we're looking into like finding the roots or the zeros of this equation, we'd set this equal to x, and then we'd have x minus 3 times x plus 1. And there we can set each one equal to 0. So therefore, x is going to equal 3 and x is equal to negative 1, right? So the important thing, though, is we can find the roots or the solutions or the zeros, and then we can rewrite it back in factored form. We can write them as their factors and your product. So since this one is not obvious what the factored form is, or at least I'm not seeing any two numbers that multiply to give you 5, add to give you negative 2, what I'm going to do is I'm going to find the solutions and then write the factors from the solutions. So to find the solutions, I'll set this equal to 0, and I'm going to use the quadratic formula. So the quadratic formula is going to be opposite of b plus or minus square root b squared minus 4 times a times c all over 2 times a. All right, so let's see here. This becomes 4. That becomes a negative 20. So 4 minus 20 is going to be negative 16. Divided by 2. Obviously, you cannot take the square root of a negative number, but we can use our real number system here. So complex number system here, and that's going to be a 4i divided by 2. Divide that 2 into both terms here, and I'm going to get a 1 plus or minus 2i. So my zeros, right, just kind of like here, is going to be x equals 1 plus 2i, and x equals 1 minus 2i. So if I have my zeros and I want to write them as factors, I'm just going to set them equal to 0. And this is something that we are actually going to work on tomorrow in my class. So that's why I thought this would be a great problem for me to work on. Okay, so now those are the factors. And if I have the factors, I can just write my polynomial in factored form. So the product of my factors, or the factored form here across imaginary or complex numbers, would be x minus 1 plus 2i. Okay, so it's not as easy. I'm assuming majority of you cannot think of that as the factored form when you're looking at that equation. So you couldn't find the solutions, though, and kind of work backwards. And that's kind of the important idea here, because obviously it'd be nice if we could just factor it, right? But when you're dealing with irrational or complex numbers, a lot of times the easier thing is to find those solutions and then rewrite them back in factored form. All right, I got 2 more questions here, guys, and then I will go back into the chat and check in on some of you guys and maybe see if there's some questions I can answer here rather quickly, even though I am kind of over my limit. But hopefully I can spend a little bit of time with you guys. So it says, find the graph reflected about the y-axis, then graph f of x equals x squared plus 2x. So, a couple things that, when I'm given a graph, and this is not in like vertex form. You could create it in vertex form by completing the square like I previously did. In previous problems. Or, one thing we can also do is, I saw somebody ask, like, how do you find the x and the y-intercepts? So, like, the x-intercept is when y is equal to 0. So, just find the x and the y-intercepts to kind of get a good idea here. 0 equals, factor out the x plus 2. So we can say x equals 0 and x equals negative 2. All right, so we have a graph that looks like that. And then at negative 2. Hopefully you recognize that the graph is going to be opening up, right? Rising to the left up. The y-intercept is when x is equal to 0. So therefore, that's going to be y equals 0, which we kind of already recognize here. If let's just have fun with this. If I did want to find the vertex, yeah, let's just go ahead and find the vertex. Let's put it in vertex form. Let's have fun with this. Oops. I already know from the perfect square trinomial, if I wanted to create a perfect square trinomial, then I'm going to need to add 1. But again, you just can't add 1 without subtracting 1, right? So vertex form of this equation would be x plus 1 squared minus 1, which tells me to go left 1, down 1, and this is what the graph is going to look like. All right, now I'm kind of going a little bit over because you don't really need to know all this stuff. But the main idea, the reason why I'm bringing this up is because if I wanted to go ahead and find this reflection about the y-axis, everything that's to the left of the graph is going to be to the right, right? And you can just move this graph then over, so therefore it's going to have that point, and the vertex is now going to be at 1, negative 1, and you can see that is what the graph would be. So having a basic understanding of how to graph it could help you out. The other thing you could do is you could also use the definition of even functions, which if you were to take f of negative x, that's going to basically take everything on one side of the equation and reflect it about the y-axis. So if I take that function and I do negative x squared plus 2 times negative x, that gives me x squared minus 2x, which if you were to find the x and the y-intercepts is exactly that equation right there. Okay, so that is just another way to go ahead and figure out what the equation is, but the question also asks to go ahead and graph it, so that's why I wanted to provide that one. All right, guys, last quick little question here. On to trig. So evaluate the arctan of 4 pi over 5, which is interesting because that's not a point that's on the unit circle. And so typically when we're doing these types of problems, we're looking for points that are on the unit circle or we're looking to create in a triangle. And we really don't want to create a triangle in this example here because, I don't see that's really going to be really going to be helpful or make this any kind of easier. But there is one thing that I remember, and obviously to, kind of keep this video not too short, because obviously this is a point where we talk about this in a long lesson, is talking about the restrictions. But, the main thing is let's figure out where exactly this point is, right? If all the way around the circle is going to be 4 pi over 5, if we were to break this up into fifths, then that's going to be somewhere into the second quadrant. But again, 4 pi over 5, so that points, okay. Actually, I was thinking that was going to be in the first quadrant, but it's not going to be in the first quadrant. It's going to be the second quadrant. So now I got to think about, crap. Okay, so the tangent of 4 pi over 5, that's in the first quadrant, that's going to be in the second quadrant. So that's going to be some negative value. Because the point was to use this without a calculator. Crap, we're going to be getting into this here, and I'm trying to think. I'm drawing a blank here. Let me go ahead and do the cos of the second one, and then maybe I'll come to it. Because this one, since it's not on the unit circle, it's not really as obvious. And obviously, I'm not going to be teaching this for a couple more months to get into this. But again, when we're doing the composition, you always want to do kind of from the inside to the outside. So sine of 7 pi over 6, right? That's going to be all the way down here. All right, and then if we were thinking about that coordinate point here, so the coordinate point is going to be negative square root of 3 over 2, comma negative 1/2. Right? So the sine of this coordinate point is negative 1/2. So really what you're asking is the arc cosine of negative 1/2. Now, however, though, we have to make sure we understand that arc cosine is basically asking us what x coordinate or what angle gives us an x-coordinate of negative 1/2. Well, for negative 1/2, it has to be in the second quadrant. Remember, the inverse cosine is restricted between the first and the second quadrant. Obviously, since it's negative, it needs to be in the second quadrant. And cosine, therefore, is going to be that angle, which would be 2 pi over 3. So, and if you look at that, if you graph 2 pi over 3, the x-coordinate is going to be a negative 1/2. Now the tangent of 4 pi over 5, that's going to be in the second quadrant, which is going to provide you with a negative value. I'm just going to chalk this one up. I have my brain fart. It was obviously I was thinking if it was like pi over 5, right? then obviously whatever that angle is, whatever the tangent of pi over, 5 is, but then if you do the inverse of that, it's obviously just those are just going to undo each other because pi over 5, that falls within the restriction. So therefore your answer would just be pi over 5 because they basically undo each other within those restrictions. However, I'm just, I don't know, my brain just hurts. I'm just going to chalk this one up as a loss. I thought I was looking at the answer and then I was thinking something different, and I'm sure it'll probably come to me later, especially when I'll teach it. I'll maybe add it in at another live sim. So I do apologize. I don't know what else to say. My brain hurts and things. So, but I do. All right. So let's go ahead and end it, at least with that. Let me see if there's maybe any questions I can do from you guys. So I'll finish off that live stream. I do apologize. I wasn't able to. If I just did from the pi over 5, then that answer would be pi over 5. From there, as those undo each other. And now I'm going to have to probably stay up and actually figure out this problem after the live stream. But that's the problem with the live stream is you are on point. So it's hey, you got to figure thing out, right? It's all the pressure on a test and stuff. It's got to think right now because you don't have time for people to hear you blabbing around, and trying to figure it out. But that's just the reality, guys, and not everything always comes to my brain, as quickly as you'd like to. So there you go. So, all right. Oh, Jeffrey, was that your question? Oh, well, then if you're allowed to use a calculator, I thought you said without a calculator. On this one, since you're allowed to, this one you don't need to use a calculator, but since you're allowed to use a calculator, you just type in the tan of pi over 5 and then take the arctan of that, or the inverse. So hopefully that helps. Basically just do the inside to the outside. All right. Sweet. Natasha's asking for there. You guys are adding in. You guys are well welcome. Genesis, I'm not sure what you mean. I think you put something in point slope form, but I'm not sure. You were from the very, very beginning, weren't you? Peachy asked me to do a logarithm, but I never got a logarithm problem. How do you find the vertex? How do you find the y and the x-intercept vortex? Yeah, just again, when you're trying to find the x and the y-intercept, just like what I did, and this is why I went through that, you're doing the same thing, finding the x-intercept, y equals 0, y-intercept, x equals 0. And that's really all you need to do to find the x and the y-intercept for you. All right, I do see a lot of you guys' questions, and I do apologize. I'm not going to be able to get back to everything for you guys. How would you solve a compound interest word problem? That is, well, first of all, for those of you that sent over some word problems, I do apologize, guys. I just don't have time to be working through word problems or to write them down or to read them. Best piece of advice, guys, a lot what I say too when I'm submitting the questions. The easier you can make it for me to answer your question, the more likely I'm going to be able to answer your question. And I do know that's not always the case. A lot of times you have questions that are not, fairly straightforward. But again, just kind of realize I'm trying to put together the live stream, or at least your questions, as quickly as possible. And so obviously if it's something that is easily understood what your question is, how you want me to do it, what you want me to do, then I can easily and quickly determine what, make sure I can do it and explain it in a way that I feel is going to be worthy of adding to the live stream. As well as, know exactly how to explain it to help you out the best. So, that's why I like students providing me equations or problems that you're working on, asking me to do graphing equations is just not really going to help. There's, infinite many equations that I could write or explain from there. So the more specific you guys can provide with questions, the better. So what is the equation? Okay, so what is the equation for point slope form when graphing lines? So let's kind of go through. So let's just kind of go through all of the equations. How about that? So first of all, we have the standard form. AX plus BY equals C. Not really a very nice equation, right? But that's kind of like your standard form. Then we have our famous slope-intercept, which is often used for graphing. Y equals mx plus b, right? Where b represents the y-intercept and m represents the slope. Then if we have point slope, there's a couple different ways you can do the point slope form. Okay, we can do y minus y1 equals m times x minus x1, where x1 and y1 are represented as like a coordinate point. So m is going to be the slope, and x1 and y1 is represented as the coordinate point. Now, again, this is basically where the slope formula comes from, because let's say you have 2 points and you wanted to find, what the slope is. Well, then sometimes you'll also maybe see it written like this. So therefore, now in this case, you have one coordinate point, x1, y1, as well as another coordinate point, x2, y2. But typically, point slope form is going to be most useful when you're given a slope and a point, and you want to write the equation of the line, and then you can easily simplify that to write it in slope-intercept form to go ahead and graph it. So hopefully that helps. But let's see. All right. 9 pi over 8. Again, how do you do the arc sine 9 sine pi over 8? Again, Jeffrey, if you have a calculator or without a calculator, I'm drawing a blank as far as what you'd want to do besides setting up a triangle when it's not in the first quadrant. Because if it's in the first quadrant, then you're going to be following with the same restrictions as the function. But I'm not sure when it's in the second quadrant. I'd have to go back and remember what you would want to be doing, because you're not going to be able to figure out that point without using a calculator or creating a triangle. So I would have to work out those problems, and obviously I don't have time to kind of work that out and to remember what to do. Sean, like I said, just found you today helping my sophomore with some geometry. Thanks for explaining in simple terms. We are now following you. Well, great, very great, Sean. I'm happy you to be on. I appreciate it. All right, so therefore come through. I see Arjun, you're asked to refine the domain and range. That's a really, really good question. Yeah, that's, sorry guys, I'm just not gonna, how do you find domain and range in interval notation? Same kind of thing. Pamela, there's, interval notation is basically just, basically asking how far left, how far right. Just remember, parentheses is not included. Brackets we used to include. But unfortunately, guys, I'm going to have to close out the question. If you typed in a question and I didn't get to it, please make sure that you follow me. I'll plan to be going live again, around this time for next Sunday. So please make sure you guys submit in the questions. I really do wish I could stay on a little bit longer and answer all your questions. But I also know how these live stream works. The longer I stay on and the more and more questions I get. So it's kind of just one of those necessary evils. I'm going to have to stop at some time and somewhere, because obviously I know I could continue going live and people would keep on coming in and keep on asking questions. So I hate to break it off to you guys now, but I feel that, that's unfortunately it's going to have to happen. And but all I can mention is, guys, if you want me to be answering one of your questions or to provide some explanation for you on the next live stream, then please just make sure that you guys are looking forward to it next week. Or obviously you guys, make sure if you're not subscribed and, the bell notification or whatever else, if you're not getting notifications from me as far as my videos, then just make sure you check that out, because I will plan on going to be going live again next week. And I also will be opening up questions again for taking your questions. So I apologize, guys, again. I know, but I really would love to answer some of your questions. I'm looking at you guys have some good questions. And hopefully for those of you that are kind of in the chat, if you guys are able to help anybody out that's still in there, I really do appreciate a lot of you guys speaking up and helping each other out, because I think that's what, makes this as best as possible. I know a lot of you guys come in for, me to help out the questions, but for those of you that can help each other out because you maybe took that class or you remember what to do, a lot of times that's what people need. They just need that little spark to remember what they're doing, or at least to provide them into the right direction. And I really do appreciate that. So thanks so much, guys. Hope you guys have a great week. And I will look forward to you guys to the next live stream. Cheers. Ooh, no, that's not going to turn off. Dang it. Thought that was going to work. Oh, yeah.